This tutorial is the part 2 of the series of the chain rules, and in this tutorial we are going to solve many more problems, derivatives using chain rules. Our first problem is y is equal tan e to the power sine 3x. To solve this problem, we have to apply the chain rule multiple times. So let's have how we can apply the chain rule. So first we need to apply on the tan, and then we'll apply on e to the power sine 3x. You know the derivative of tan is secant square, so we have secant square, and inside e to the power sine 3x will be as it is. Then by the chain rule we have to, next derivative is derivative of e to the power sine 3x. The second step, we have secant square e to the power sine 3x as it is. Then derivative of exponential function is exponential function itself, so we will write e to the power sine 3x, and then again apply the chain rule. The next derivative will be derivative of sine 3x. In third step, write the first two term as it is, and then derivative of sine is cosine 3x inside as it is, and then again apply the chain rule, and we have the last step is derivative of 3x. Since the derivative of 3x will be 3, so after rearranging the terms you will get your final answer as written here. Our next example is y is equal sine x to the power 3 e to the power 2x. So here we will solve this by the chain rule. So first apply on the sine, and then using the product rule you will have the derivative for x to the power 3 e to the power x. So when we apply on the sine, so sine derivative is cosine. So cosine x to the power 3 e to the power 2x, then derivative of x to the power 3 2x. Now we will apply the product rule, and x to the power 3 derivative of e to the power 2x, and the derivative of e to the power 2x will solve it by the chain rule, plus e to the power 2x derivative of x to the power 3, and which can be solved by the power rule. In the next step, we need to apply the chain rule on e to the power 2x, and then derivative will be e to the power 2x derivative of 2x plus e to the power 2x, and derivative of x to the power 3 is 3x square. Since the derivative of 2x is 2, so writing the terms in arranged way, you will have the final answer. Our next problem is to find the derivative of tan to the power 3 sine square t. So to find that we have to apply the chain rule many times. So first we will apply power of 10. So power of 10 is 3 here, and the derivative of tan to the power 3 will be 3 tan square sine square t, and then derivative of tan sine square t. Derivative of tan is secant square, so we have 3 tan square sine square t secant square sine square t. Again apply the chain rule on sine square t. Now power of sine is 2, so the derivative will be 2 sine t, and then by the chain rule derivative of sine t again, which will come as cosine t. Now since 2 sine t cosine t is sine 2t, we have our final result as 3 sin 2t tan square sin square t secant square sin square t. Our next problem is y is equal to the power x to the power 3. So this is an easy problem to solve by chain rule. So it's given as dy dx is equal to dx. First we will apply the derivative on exponential function, and then we'll apply the derivative on x to the power 3. So d dx e to the power x to the power 3. So by chain rule we have e to the power x to the power 3 as it is, and then multiply by derivative of x to the power 3. Now derivative of x to the power 3 is well known, which is 3x square so just rearrange the terms and you will have the final answer. Our next problem is the word problem that find the value of f composition g, its derivative at x is equal to 1, where it's given as f of u is equal to the power 5 plus 1 and g of x is equal u is equal e to the power x. So first we will derive the composition. So f composition g dash is f dash gx and multiply with derivative of g. So f dash is u to the power 5 plus 1. So the derivative will be 5 u to the power 4. So therefore f dash gx will be 5 gx to the power 4 multiply g dash x, which is 1 over 2 square root of x. Now gx is equal to square root of x. So we will put the value of gx, which is square root x to the power 4 and 1 over 2 square root x multiply. So if after simplification we will have 5 over 2 and x is equal to 1. So we will get the value is 5 over 2 at x equal